With the completion of your Chapter 18 test, we have now finished all of the notes for the entire year. At this point, we are now ready to start reviewing for the AP exam. And this year, we only have to focus on what they call Units 1 through 7. Those don't exactly match up with the Units 1 through 7 in our textbook. So what I'm going to do for you is I'm going to lay out exactly what does each one of the AP College Board's units hold inside of it. And we will practice problems from each one of these units in an attempt to get us ready for the best possible grade that we can get on this AP exam. So today's notes are going to focus on a review of what the AP College Board calls their Unit 1. And we're going to delve into, now I've already given you a list of what all the units contain, but we're going to delve much deeper into what exactly is in these units. And we're also going to take a look at what types of questions they could throw at you. So Unit 1 in the AP College Board curriculum is on primitive types. We're going to look at different kinds of variable types. We're going to look at expressions and the assignment operator. We're going to look at compound assignments using the and the or. We're going to look at typecasting and the range of different variables. So these are some of the main topics that are in what the AP College Board calls their Unit 1. So what I've got below here, and I've got a bunch of different concepts, and whenever possible, I'll try to demonstrate it with an example. So the very first thing that you need to know is the intrinsic type of variables that they focus on. There are 8 intrinsic types, but they actually only focus on 3 of them in the AP exam. They focus on integers, doubles, and Boolean. So you won't see long or short or byte or float. In fact, what's kind of weird is you won't even see char, which is characters. So it's just these 3 types that they will focus on the AP exam. Remember, putting the keyword final in front of a variable makes it a constant. And that means once you've set the variable, once you've set that variable's value once upon creation, you would not be able to change it. Trying to make any change to a final variable would result in an error. Next, expressions consist of a combination of variables and operators. So we've got different types of operators and variables. The variables could also include constants as well. So the different arithmetic operators are adding, subtracting, multiplying is with an asterisk, dividing is with a /, and this guy right here, which is modulus division. Remember, modulus division is the one that's responsible for giving you the remainder of a division, not the quotient. So your arithmetic operations that use only integers to evaluate will evaluate to becoming an integer. So remember, if Java sees, for example, an integer getting divided by an integer, it's going to give you an integer answer. This is one of the things they almost always test on. So for example, 7 divided by 2 in Java is going to be 3, not 3.5, which is the correct answer. So any kind of decimals are going to get truncated here because Java sees 2 integers and thinks you're going to want an integer as an answer. Arithmetic operations that use at least one double value within its calculation will evaluate to becoming a double. So if you did 7.0 divided by 2, then you would get the correct answer of 3.5, not the integer version of 3. However, if you're not happy with the level of precision that Java is going to give you, you can always do something called typecasting to tell Java what you expect as a result. Now, the way that typecasting works is you say what type of precision you'd like inside of parentheses, and then you do your computation inside of parentheses behind that. So normally 7 divided by 2 was going to give us 3, but when Java sees that double in front of it, you're basically telling Java, I want you to do this calculation with double precision, and therefore the answer will come out to be 3.5, which is the correct answer, and no truncation of decimals will happen. So this is called typecasting while you're doing the computation. The relational operators that we have are greater than, less than, greater than or equal to, less than or equal to, equal to, or not equal to. And these can only be used with intrinsic types. So these comparisons are between things like integers or doubles or booleans. You wouldn't be able to compare two bank accounts with a greater than symbol, or you wouldn't be able to compare two dogs with a double equal to see if they're equal. It won't work correctly on that. Well, it won't work the way you think it would. We do also have logical operators of and or, and we also have the logical operator of not, which you just saw right there. The not is the exclamation point. The and the or logic operators can be used to create compound statements. The and operator needs both parts to be true in order for the whole thing to be true, while the or operator is true if either of the first or second parts is true, or if they're both true. So if I gave you this compound statement, x is greater than 0 and x is less than or equal to 124.50, this was something that we saw in our payroll account. We were trying to look for somebody's adjusted gross income that was between 0 and $124.50. This would return true for any value of x. Now, check this out. It's greater than 0 or less than or equal to 124.50. Okay, so you'd have to be in between these two numbers to satisfy both of these at the same time. If I had changed this from an and to an or, that gives a whole different meaning to this sentence. Either you're bigger than 0 or you're smaller than 124.50 actually encompasses all the numbers on your number line. So any negative number would be smaller than this, any positive number would be bigger than 0, and even 0 itself would be less than 124.50. So actually, this is going to return true for all real numbers. So be very careful when you're picking your logical operator, because that makes a big difference in terms of what kind of answers you're going to get. During the evaluation of a Java expression, we use our operator precedence order. So that's what they call it in Java, but in math, we just call it our orders of operation to determine the order for processing. So things like parentheses come first, exponentials, then multiplication, division, addition, subtraction. The and the or operators come later, but usually we use parentheses anyways to indicate like what we want done first. So just make sure you know your orders of operation for working with a Java program. If you attempt to divide an integer by 0, that's going to result in something called an arithmetic exception. We learned about exceptions in chapter 15. However, if you divide a double by 0, that is not going to throw an exception. Instead, you're going to get the word infinity as an answer, which is kind of weird, but that's what happens in Java. For the primitive types, or what we've been calling all year intrinsic types, you do not need to run a constructor or use the keyword new to help you create memory for the location. So as soon as you say int x, this creates a memory location for x. This is for intrinsics only now. If you do not assign a value upon declaration, Java immediately assigns an intrinsic value as a default value. So for doubles and for integers, you're going to get a value of 0. Well, technically for doubles, it's going to be 0.0, but essentially it evaluates to 0. For booleans, the default value is false. The equal sign is called an assignment operator, and it evaluates what's on the right-hand side of the equal sign first, and then stores the value into the variable on the left. So for example, double y equals 3.0 times 17 minus 12 minus 4 inside of parentheses divided by 2 is eventually going to give you the value of 47, well technically 47.0 because it's a double. But I just want to show you the orders of operation here. First it's going to do what's inside the parentheses, which is 12 minus 4, that's 8. Then it's going to do the multiplication. 3.0 times 17 is 51.0. Then we're going to do the division. 8 divided by 2 is going to be 4. And then 4 gets subtracted from 51. And that's how I get 47. But technically, it's actually going to be 47.0. We also learned that there are these things called self-assignment operators. And that's when you see either the plus, the minus, multiplication, division, or even modulus division in front of an equal sign. And what that means is actually happening there. It's performing the given operation on the right-hand side with the current value of the variable and then reassigns that value back into itself. So for example, if you saw x plus equals 7, what that means is I want you to add 7 to the current value of x and then restore it back into the value of x. So if x was 5, you would take 5 and add it with 7, which is 12, and then put the 12 back into x. The next thing I want to review with you are what are called the increment and decrement operators. Those are the plus plus and the minus minus symbols. That's adding 1 and that's subtracting 1 to the current value of your variable. And this can be put in what's called a prefix or a postfix position. Now it turns out in the AP curriculum that they do not actually test you on the difference between putting the plus plus in front and putting the plus plus behind. But I thought I would review it anyways since I'm trying to be as complete as possible. Remember, putting the plus plus in front makes you add 1 to the current value of x immediately, and then any other calculation that you're doing would use the new value of x in it. So for example, in this particular problem, x starts out at 5, and I'm trying to make a new variable called y, and I'm going to plus plus x and then divide by 2. So that means the value of x gets 1 added to it right away, so x is now 6. And then I'm going to divide 6 by 2, which gives y a value of 3. However, if we did this same problem and put the plus plus behind, what that means is x is going to have 1 added to it, but not right away. The 1's going to get added to it after it does the rest of the calculation. So it uses the current value of 5, divides by 2, and gets a y value of 2 assigned, and then I will add 1 to the x value later. So x would end up 6 and y would end up 2. So the reason why y gets 2 is that we did not add the 1 to x immediately. And remember, Java does weird things when you're dividing integers by integers. So 5 divided by 2 according to Java is 2 because it truncates the 0.5. And last thing that you need to know is the integer of the range of values that we can use for integers. There is this special integer called integer dot min value, and another special integer called integer dot max value. These are the highest and lowest values that the integer variable can go up to. As long as your integers are within this range from the min to the max value, so this would be some kind of really big negative number, and this would be some kind of really big positive number, as long as you're in between those, integer is going to work just fine. If you try to assign a value that is smaller than the minimum possible value or bigger than the maximum possible value, you're going to get what's called an overflow error message. Okay, so it'll tell you that the number that you're trying to use is outside the range of integers. For example, if you did factorials and kept going, you'd eventually get factorials that are so large they'd be bigger than the max value, and therefore they would give you an overflow message. You are now ready to try the problems in the personal check. Start with part 1, and then later on I will assign part 2, and I'll show you the solutions for these in the upcoming days. Thank you for listening.